I'm a financial economist, and this paper is on environmental economics. And it is a natural thing for a financial economist to do. In financial economics, we deal a lot with uncertainty. And there are very few problems in economics that have so much uncertainty as this type of problem. What we're going to try here is to develop a framework to analyze this problem, and we're going to calibrate it with as much data as possible. Most of the studies in environmental economics starts before the beginning of the industrial age, when man started making big emissions into the atmosphere. At that time, the concentration of CO2 in the atmosphere was 280 parts per million. That's how you measure concentration of CO2. Since that time to today, it has increased to 400. Today we have about 400 parts per million. Okay, so what do we ask here? So what the questions we are here is, can we stabilize the climate change? Can we do something to do that? And what will it cost to do this? What will be the cost involved in this? So for that, we propose an optimizing base general equilibrium model of carbon abatement. How much should society optimally invest in techniques or methods to lower the amount of carbon in the atmosphere? Some of our main findings is that if we start with the optimal abatement capacity now, we have a 65% chance that the target of 2 degrees would be met. 2 degrees is considered like the temperature increase from the pre-industrial age. This is average in the surface of the Earth. That would be, the society could actually adapt to, okay? More than that, there is a big debate whether it's possible or not. So we take that as a benchmark, okay? But if we do a lot of experiments, but one of the experiments we do, let's say that you wait 10 years, and 10 years from now you start with the optimal policy. In that case, we calculate that the probability of getting to that target would be only 25%. And if we wait 20 years and then we start with the optimal strategy, then the probability would be less than 5%.